All right, part number 2. So we got to finish up these notes. So we just got done talking about nonpolar, the nitrogen, and polar, the water molecule. Right? Oh, there goes my light. Let me get my lights turned back on. All right. So then there's a thing called a surfactant, and what a surfactant does is it actually interrupts. It messes up this polarization attractions between the molecules, and we can like get in between those molecules and kind of cause them so they can't be attracted to each other. And an example of this would be soap, right? And the way in which it does it is that soap, I'm going to get rid of this nitrogen up here. Soap has a special arrangement that it's put together as. And what it ends up looking like is we get this little head, here's the soap, and then it's got a little tail that sticks off the backside. Right? And what this is that the head part is polar, so this end is polar, and then the tail part is non-polar. I just lost my cap. I'm gonna grab my cap so my marker doesn't dry out. All right. So now you look at this and you go, well, wait, Mr. Pape, just a minute ago you said polar and non-polar aren't attracted to each other. You're right. So what we have to do is we have to do a special little chemical reaction in order to get these two things to go clink, clink, and bond together so that we can have this special molecule. What I always like to tell my classes to do is I have a little assignment for you to try sometime, and I want you to talk to your grandma and grandpa, all right, or somebody that you know that's older, right, like maybe in their 60s, 70s, or 80s, all right. Probably your parents way too young, they won't know this because they didn't live long enough ago. But if you ask your grandparents or somebody that's like 60 to 80 years old and ask them about when they were a kid, if they remember making soap, and maybe they'll be able to tell you, oh yeah, I remember doing this. I remember when my dad, which would have been their father, would be your great grandpa. I remember he used to kill the family pig. It's like, oh my gosh, yeah, well, that's how they got their meat, is they kill the pig and make pork chops and hams and all that, and then they'd take all that and cure it so that they could save it and have it to eat later on in the year. Well, then in doing that, they also ended up with a whole bunch of fat. And that fat, what they would do is they would take it and they put it into a big old witch's cauldron. And they would start to heat it. And as they would heat it, that fat would turn into a liquid. And then once they've been heating it long enough, then they take this little special stuff called lye, L-Y-E. It's also sodium hydroxide, NaOH. And they take a little bottle of that and they pour it into the melted soap. And then they'd sit there and stir it, and stir it, and stir it, and stir it, and stir it a whole bunch of times for a long time on that heat. And what that's doing is it's actually causing these little things to bond together. And what we're getting is that polar head, that's going to be from the lye, or actually a base. That's what lye is. It's a really, 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 really strong base, really, really dangerous. You come in contact with it, it'll burn your skin. It's really nasty stuff as lye. This nonpolar tail, that comes from the pig fat, because the fat is a nonpolar substance, and by heating it we get those two things to bond together and make into soap. And then if you ask that grandparent, they'll be able to say, oh yeah, then after we got done doing that, we put this big old cookie sheet on the like the picnic table outside, because they do this outside usually, and then they take that cauldron and they pour that mixture inside that big old cookie sheet, and then they let it cool. And as it would cool, because this is made out of pig fat, which is a solid at room temperature, once it cools, it would all turn into a solid. And then they take a big old knife and they cut it into little blocks, and then they have their soap for the entire year. And their soap came from their pig fat that they use. And guess what? Did you know a bunch of the soap that we use today still uses pig fat? So that means like tonight when you're like in the bathroom washing up and you're like washing your face with soap, you're like, oh man, I'm getting my face up. You're actually washing your face with pig fat. Right? But it's fine, because that's what makes it so you can get the oil off your skin so that you don't end up with acne or anything like that, and it helps clean everything. And we'll talk about that as to how that works in a moment. So, all right, so understand that this is made out of pig fat, okay? So now, how do we get oil off of our hands? So if we get rid of my water molecule now. So here's a little big old blob of oil on your skin. And that oil is non-polar. So because it's non-polar, if I take that soap and I rub it all over my hands, what's going to happen is one piece of this is going to get attracted to that oil. Well, which part ends up being attracted? The non-polar tail. So the non-polar tail ends up being attracted to it. And the more I scrub my hands, the more of these little molecules, they get attracted to that non-polar oil. And I can get that oil all surrounded by all these little things sticking outside of it. Now, what part is sticking out? Well, we got this head part, which is polar. So now if I happen to take some water and want to run polar water by this, the polarness of that water is going to be attracting those polar heads, and all of a sudden it's going to pull that oil off your skin, and you can wash it into the sink and wash it down the drain. And if you didn't have these guys all attracted and you run water by it, the non-polar oil and the polar water are not attracted because they're not alike. So you won't be able to get that oil off your hands with just water. You got to have that surfactant, that soap in between, because it's such a unique molecule because it's got both of these pieces to it. So, all right, so let's look at our notes again. And going through our notes, how do we get oil off our hands? Number 1 says non-polar tails of the soap molecules are attracted to the non-polar nature of the oil molecule. That's what I tried to show you there. Right? Then the oil molecule becomes surrounded by soap molecules with polar heads sticking out. And that's what I showed you out here. There's all the polar heads sticking out. Number 3 is water passes by, the polar heads are attracted to the polar nature of the water, and the oil is pulled off the skin. And that's what I was trying to show you over here. Okay, so you might want to actually draw this picture in your notes, because you might need that later on in order to help explain this sometime later. Letter F, to make a bar soap, we use a fat, which is a solid at room temperature. That's what I told you over here, and using pig fat. Okay, and really, yes, they will use pig fat because it's a nice, easy thing to get. We do make a lot of pork chops, hams, things like that, and so there is a lot of oil out there, a lot of pig fat out there, so we can use that in soap manufacturing and make soap. Now you might go, man, I don't know about you, my soap don't smell like pig fat. You're right, because what they do is when they make that soap stuff, they'll actually add some perfume to it so that it smells pretty. Right? But you can actually buy soap that doesn't have that, and it really has no smell. It doesn't smell like pig fat. It just really has no smell at all, but it will still clean you. All right. Now, what about in my bathroom? I have a little pump thing that squirts out liquid soap. Well, how in the world do I get that? Well, I don't use fat. Instead, what I'll do is I'll use an oil, like some sort of plant oil or something like that. And plant oil is a liquid at room temperature. So when I do the same idea and combine it with some base, and I can end up making liquid soap. All right. So depending upon what kind of fat I use over here will determine how well this is going to work. All right, that can influence it. Also, what kind of base I use will also determine how well that soap will work. Now I have another little experiment for you to try. Next time, sometime when you're taking a shower, I want you to do is see if you can ask your mom or dad or whatever and ask them, see if you got any baby shampoo in the house. Right? And if they do, say, man, can I have some? I want to wash my hair with it. All right. So, and then take that with you into the shower and take a little bit of it and then wash your hair with baby shampoo. But I'm going to give you a hint. Don't do it on a day when you got something planned to do that day. Because what you're going to find is you're going to end up with your hair not being very clean. Because how do they advertise baby shampoo? Why do we use baby shampoo on little babies? Because it causes no tears. Because if it gets in the little baby's eyes, because they're going like that, and they're bouncing around playing in the water, and it splashes in their eyes, and it doesn't make them start to tear up. Where if you think about like when you've been in the shower and you're washing your hair with your normal shampoo, and you get some of that down in your eyes, and you're like, oh my God, oh man, it burns like crazy. Hey, and it's because, why does it burn? It's all because of this guy over here. If you remember when we talked about the rules in here, we said that bases, if you get it in your eyes, it can make you go blind, right? And that base that's in soap, in shampoo, is what burns your eyes. It's not the fat molecule, it's the base molecule. So what do they do in baby shampoo? They use a really, really, really weak base, so that when it gets inside the baby's eyes, it doesn't burn their eyes. Now, also, that means if I do this, all right, and use baby shampoo, yep, it's going to be attracted to the oil in my hair, but these polar molecules on the outside, they're not very strong. So when I run water by it, it doesn't pull it off very well. Okay? So I'll still end up with the oil all over my hair, and what you'll find is you may take your shower, let's say at 8 o'clock in the morning, and by about 10 o'clock or 11 o'clock, you can be like, oh my gosh, I don't even think I took a shower. My hair feels so nasty. It's all oily, and it's because you didn't get all the oil out because it doesn't have that really strong polar head like we're normally used to. Now, why do they use it in babies? Well, because babies don't have a lot of hair like me, so it doesn't take very much. And also, we like give babies a bath, in the morning, the afternoon, and nighttime. We give them baths like all the time because they love to sit in water and splash the water all around. So it's entertaining for them. So that's how those things work. So, and that, I believe, finishes our notes. So we'll talk to you later. Have a great day. See ya.